This is Derek, and this is Chapter 5, Operations with Polynomials, and this is going to be the first of 3 videos. This one is going to be addition and subtraction with polynomials. And so let's see. Polynomials have a lot of terminology that's coming up here. And so let me just try to get through some of the definitions. And then once you know what the words mean, the actual problems in this section are probably one of the easier sections of the quarter. It's actually super straightforward. So first off, we have terms or mononomials. So a term or mononomial is a constant or the product of a constant with one or more variables raised to a whole number exponent. So that's a lot of words. Here's what it would look like. Here's our constant, which is like a number times a variable raised to a whole number exponent. So that's a mononomial, or what we're going to also call terms. And so the other examples I have here of terms would be like a -5, that would be a term. X cubed yz squared, we can have more than one variable, still a term because it's just a bunch of variables with whole number constants. The degree of a term, for a constant term, it's degree 0. The reason for that, and we'll see this more in the next chapter, right now we're just kind of going to leave it at it is degree 0. But here's the how come that's coming up. It turns out there's an invisible x to the 0 right here, and anything to the 0 is going to be 1. And we'll see that when we get to the next chapter with exponents. For right now, I'm going to leave it a little bit more as a definition, but we'll make better sense of this in chapter 6. But so constants are degree 0. This would be degree 3. This one we would add up the exponents. So we have 3. That y is an invisible 1. So 3 plus 1 plus 2 would make 6. So this would be degree 6. A polynomial is a finite sum of terms. So it's a finite sum of these sorts of things. And mononomials have 1 term, binomials have 2 terms, and trinomials have 3 terms, which makes sense. Get down here, the degree of a polynomial is its highest degree of its terms. So say I had 2x to the 7th minus x to the 4th plus x to the 9th. This would have 3 terms, and the degree of this polynomial would be 9 because it's the highest degree in the terms. And then the part up here where it said polynomials have whole number exponents. So let me show you a couple examples of what they don't have and what they can have. So just a constant term like, a 7, that's a polynomial or a mononomial because that's our 7x to the 0. But if I have an x in a denominator, that makes it not a polynomial. If I had an x with a negative exponent, that's going to turn out to be the same thing as an x in the denominator. So that would make it not a polynomial. If I had an x under a root, that would also disqualify it. Likewise, an x to a fractional exponent, because it turns out these are the same thing, that would also not be a polynomial. So the 7 was fine, and then everything else I wrote there makes it not a polynomial. Okay, so identify a polynomial. So when you look at this on the homework, it will have this sort of list of descriptions, and it'll have a list of equations, and you're just picking the one that matches the description. I'll just make up some answers here to sort of explain. So for this, give an example of each type. So binomial of 4th degree. So if it's a 4th degree, that means it's going to have an x to the 4th. It could have a coefficient out front, but the largest power in this is going to be x to the 4th. That's a binomial, means it has 2 terms. So I could throw an x there, I could throw an x cubed, whatever I want, but it has to have 2 terms with the biggest power of 4. A mononomial 1st degree, so easiest one I can think of is x. So that has 1 term, mononomial 1st degree, x to the 1st. I could have that be 5x to the 1st. I could have, x over 3, that's the same thing as 1/3 of x. Those are all 1 term with x to the 1st. Monomial of degree 0, so that's a constant, so that would be like a number, like 1 or 5 or root 7. We can have roots, we just can't have variables under roots. And then a trinomial, so that means we're going to have 3 terms, and then the biggest power is going to need to be 2. So I'll start off with x squared. I can't go above squared, so next up would be an x. And then after that, I could do a constant of some sort. So here, this is asking which of the following are not polynomials. So that has a x in the denominator, so that would be no. 7, that is a polynomial. It's a monomial, but monomials are part of the polynomials, so that would be yes. 1/4 x minus 2/3, so that is an x to the first, and so that's just a linear equation. That is a polynomial, so that would be yes. This one has a root and an x in the denominator, so that is a no. Y over 4 might make you feel like it's not a polynomial, but it's the same thing as 1/4 y, and that is y to the first, and that makes it a polynomial. So that one would be yes. Give the degree of each polynomial. So remember, the degree is the largest power, so this would be degree 4, and this would be a degree that's an invisible 1 up there on the x, so degree 1 here, and degree 4, like that. And then write the polynomial in descending powers of x. So descending means start with this largest one and then work your way down from there. So this is 8 plus 5x minus x to the 5th plus 3x to the 4th. It's a little bit small in case you can't see it. So the x to the 5th is the largest power, so that's where I want to start. And it's got a negative in front, so that comes right along. Whatever is in front comes with it in terms of the sign. Plus 3x to the 4th, so that goes next. Next up we go plus 5x, and then plus 8. So that'd be writing in descending order. Okay, and then the actual adding and subtracting of polynomials. We've done this already. We've collected like terms that we limited ourselves to linear equations. And so now we're going to get things with a little bit more going on in terms of the exponents and the variables. So like terms are where everything is the same except for the coefficient. And remember, the coefficient is the number in front. So this is 5x to the 4th, y to the 3rd, and then 8x to the 4th, y to the 3rd. This stuff is the same, so that makes them like. Here, these have the same coefficient, but x squared y versus xy squared, those would not be like terms. So remember, we can add like terms, we can't add not like terms. And so, come down here. So this one is 9y cubed minus 4y cubed. And then this has this minus, a minus, so I'm just going to show that as a plus 6y cubed. And then remember, when we're adding things, like when we're doing this with x's in the linear section, it didn't change the x. We were just counting up how many x's we have. Here we're just counting up how many y cubes we have. So here we have 9 minus 4, which would leave us 5y cubes, plus 6 more would give us 11y cubes. So the y cubed doesn't change. It's just we're counting how many we have. Over on this one, so we have a couple of like terms to combine. So that's 7x squared, and it's generally we'll write things in descending order. Occasionally there's a reason not to. It usually involves the signs, but most of the time we'll go with descending order. So this one has a plus 2x and a minus 5x. We can simplify that down to minus 3x. And then plus 3 plus 10, we can write that more simply as plus 13. Okay, so number 7, these parentheses are doing absolutely nothing. It's just kind of showing that there was one polynomial plus another polynomial. So I'm going to rewrite this a little bit larger, and I'm going to drop the parentheses. Okay, so the exact same thing, just no parentheses in there. The parentheses will matter when we subtract, but for addition, they're pretty much just for show. And now what we're going to do is kind of gather up our like terms. So I have 6x squareds here, and I have 7x squareds there. So that will make 13x squareds altogether. Here I have minus 3x's plus 2x's, so we're down 3 and back up 2. So that puts us at like minus 1x, which we'll write as minus x. And then plus 4 minus 10. So up 4 and then down 10 will put us at minus 6. So that's as simplified as we can get. Okay, so for subtraction, we want to think of this negative as like a negative 1 that has to get distributed. And we saw this back in chapter, I think 2 it was, when we were doing this with just sort of linear expressions and equations. But so we just got to make sure that we get that sign distributed. So rewriting this, we'll have 11x to the 4th minus 7x cubed plus 2. And I just get this exact same stuff, but with the opposite signs all the way through. So it was plus, plus, minus, so now it's minus, minus, and plus. And now we just go right back to collecting like we did up here. X to the fourth is all by its lonesome, so it will just stay the 11x to the fourth. Here we have minus 7x cubed minus another 7x cubed, so that's going farther into the hole, so that's minus 14x cubed. Minus 2x squared would be next, just going in order. And then plus 2 plus 5 should give us a plus 7 right there. Okay, so this last one goes, Gray Outdoors sells specialty tents for high altitude camping. Their cost for producing tents is given by this equation, and the revenue from selling the tents is given by that equation. Write a polynomial for the profit that they make for selling tents. And then down here they have this hint where it's like, recall that, you haven't seen this, it's okay. But profit equals revenue minus cost. Because what profit is, right, is how much money you get to keep. So your revenue is how much you took in, your cost is how much it took you to make that money. So revenue minus cost, the difference in there, that's profit. So we're just gonna go this polynomial minus this polynomial, which is what this is all about, is subtracting polynomials. So here we're gonna say profit is gonna equal 2700x minus 4x squared minus the cost function up here. X cubed minus 14x squared plus 80x plus 100. And so now that I got that set up, I'm gonna cut away and I'll rewrite this with the sign distributed. You can do this just all in your head. I'm gonna show this step just so I don't lose people. And so there's this, so minus and then plus and then minus and then minus. And then let's sort of gather up our like terms. So the profit will be, that is our only cube, so x cubed. We have a minus 4x squared there, and then the plus 14x squared there. So that would leave us plus 10x squared, 2700x, and then minus 80x. So that's going to be 2620. And then just that minus 100. And so that would be the profit. And then part B was find the profit for selling 10 tents. So that just means you're going to put 10 in for all these x's. I'll just write it out right underneath here. And then if you just chunk all that into a calculator, this comes out to quite a lot of profit for, these are some spiffy tents, $26,100.